Hi there. This video is an exam paper walkthrough of the AQA GCSE Mathematics Higher Tier Paper 2 from summer 2023. This paper is worth 80 marks in total, and this is the fourth video of 4. It will focus on questions 21 to 26, which account for 20 of these marks. AQA Paper 2s are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 21. Megana decides to put £500 into an account that pays compound interest. She wants to have at least £560 in the account after 3 years. Work out to one decimal place the minimum annual interest rate that she needs. So if we knew the interest rate, what we would do would be the amount multiplied by the interest rate to the power of 3. And what we'd be wanting is that this value would be at least £560, so greater than or equal to £560. But we don't know what this interest rate is, so let's call that x. And then we've got ourselves a bit of an inequality that we can have a go at solving. So 500 multiplied by x cubed, so remember x is our interest multiplier, so we need to remember that, is greater than or equal to 560. So let's divide both sides by 500. So x cubed is greater than or equal to 560 over 500. So let's work out what that is. 560 over 500. So x cubed is greater than or equal to 1.12. So let's figure out what x should be. So it's greater than or equal to the cube root of 1.12. Oh, wrong button. Which is 1.03849882. So remember, this is that multiplier. So the one part isn't included in the percentage interest. So actually the percentage interest is 3.849882%. We want it to one decimal place. One decimal place, so we could say that it's 3.8% to one decimal place. 22. An approximate value of a root of an equation x can be found using the iterative formula, and they've given that here for us. The starting value is x1, which is equal to 4. Part A, work out the values of x2 and x3. So the way an iterative formula works is you use the previous value to find the next value. So this would be xn, and then xn plus 1 would be x1 plus 1, which is x2. So to find the next value, we use the previous one. So we're going to use this iterative formula, but instead of xn, we're going to put the value for x1, because we're going to use x1 to find x2. So we have 5 times 4 squared, subtract 2 times 4, subtract 3. What you see here is what I'm going to enter into my calculator. Okay? So we have the cube root of 5 times 4 squared, subtract 2 times 4, subtract 3. And then I'm going to press equals. So x2 is 4.101565593. Now I'm going to go through and I'm going to use this value. So that's my answer, okay? So let's change this 4.10156593, 4.10156593. So x3 is 4.17764168. (22b) By continuing the iteration, show that the value of x is more than 4.25. Okay, so to continue it, we're going to find x4, x5, x6. Let's see what they give us. Now, to make our life easier, this answer that's stored, we're now going to go back to this, delete the previous answer that we put in. I'm going to press our answer button, and then it'll use the last answer that we generated, so we don't have to keep typing those values in. So if I press equals, so x to the power of 4 is 4.234116778. Press equals again, it's using the previous answer because I've used the answer button. So 4.275769448. Then again, 4.30634511. So what we're going to say here, we're going to stop here because it wants us to continue it to show that the value of x is more than 4.25. Well, it's already gone above 4.25 with the 5th and the 6th value here, so it's just going to keep going. You can press your calculator to check. It will eventually show down, but they're all going to be bigger than 4.25, so we can stop at that point. Question 23. Here are 3 sets of cards. We've got set A, which is 8 cards, set B, 3, 6, 7 cards, set C, 4 cards. In a game, a player has 2 options. Option 1, pick 2 cards from set A. Option 2, pick 1 card from set B and 1 card from set C. The cards are picked at random. The player wins if the total of their 2 cards is exactly 10. Which option gives a better chance of winning? Option 1 or option 2? So we need to find the probability of winning in option 1, probability of winning in option 2, and then compare them. Okay, so if we're looking at option 1, if we want a total of 10, the only way we can make a total of 10 in option 1 is to do 5 plus 5. There are no other cards. If we added them together, we'd get an exact total of 10. So let's work out the probability of that happening. So if we pick out the first card that's a 5, we're picking out of 8 cards, and there are 1, 2, 3 possible options that we pick a 5. And then for the second card that we pick, because we're picking 2 cards from set A, there would only be 7 cards to pick from because we've already chosen 1, and that would leave 2 5s to pick from. So 3 times 2 is 6, 8 times 7 is 56. So we've got a 6 out of 56 chance. So option 1 is a 6 out of 56 chance of winning. Okay. Option 2 is that they pick 1 from set B and 1 from set C. So we need to figure out how many of those combinations would give us a total of exactly 10. So what I'm going to do for this is I'm going to sort it into a bit of a sample space diagram. So set C, so here we've got set C, and then here we'll have set B. So set C, the options are 3, 4, 5 and 6. I just find it easier to sort information into diagrams. And then for set B, we have 1, 2, 4, 6, 8, 8 and 9. So we can extend our lines there. Doesn't have to be perfect, it just has to organise the information for you. So when they pick each card, they total. So 1 plus 3, 1 plus 4, 1 plus 5, 1 plus 6, 2 plus 3, 5, 6, 7, 8. 4 plus 3 is 7, 8. 6 plus 3, 8 plus 3, 8 plus 3 again, and then 9 plus 3, and then we're adding all the others, but obviously we're spotting that they're going up in consecutive numbers. Exactly 10 then, so 1, 2. So out of all of those possible outcomes, there are 2 that give us a total of exactly 10. So for option 2, when we pick, we'll have 2 out of, so we've got 4, 8, 12, 16, 20, 24, 2 out of 28. Okay, now what we need to do is compare these two values. So I've got a fraction out of 56 and a fraction out of 28. So what I'm going to do, so for option 1 is 6 out of 56. Option 2, if I multiply that fraction by 2, 28 times 2 is 56. So that would give me 4 over 56. So now they have a common denominator. I'm able to compare them. Okay, so which option gives a better chance of winning? Well, this is option 1 here, and this is option 2. Option 1, the denominator is the same, but the numerator is bigger. So option 1 is a greater probability than option 2. So we select option 1 out of the 2 boxes. Question 24. A equals 65 to the nearest integer. B equals 30 to one significant figure. Work out the upper bound for 2a squared subtract b squared. You must show your working out. So straight away, they want us to work out the upper bound for this calculation. So I'm going to need the lower bound and the upper bound of these two values. So let's start with a. So the upper bound of a. So if we're rounding to the nearest integer, we're rounding to the nearest 1. Half of 1 is 0.5, so the upper bound would be 65 plus 0.5, and the lower bound would be 65 subtract 0.5. So we have 65.5 and 64.5. Let's do the same for b then. So we want the upper bound and we want the lower bound. So b is rounded to one significant figure. The first significant figure is the 3, which is in the tens column. Half of 10 is 5, so the upper bound we would add 5, and the lower bound we would subtract 5. So 35 and 25. Now we need to look at these calculations and figure out which value for A and which value for B we're going to use. So we want the upper bound. So we want the maximum answer for this calculation, the biggest answer we're going to get. So to get the biggest answer, we want to use our biggest number subtracting our smallest possible number. So if we want 2a squared to be our biggest number, we're going to have to use the upper bound of a to get the biggest number. So we're going to use a equals 65.5. And then to subtract the smallest possible number to get our maximum, our biggest answer, we're going to want to use the smallest possible value of b. So we're going to use the lower bound for b. So we're using a as 65.5 and b as 25. And then we're going to substitute these two values into this calculation. So we have 2 times a is 65.5 and it's squared, subtract 25 squared. So let's stick that in our calculator. 2 times 65.5 squared, subtract 25 squared. So we get 7,955.5, and that's what we're going to pop on our answer line. Question 25. Show that this algebraic fraction, adding this algebraic fraction, can simplify into that form where a and b are integers, and integers means whole numbers. So we're not wanting any messy decimals or anything like that. We want them to have whole numbers where the a and the b are. Okay, so we've got algebraic fractions. So yes, they look messy because they've got algebra, but we know how to add fractions. To add fractions, we need a common denominator. So what we're going to do, we're going to multiply this fraction, top and bottom, by x plus 2. So x plus 2 multiplied by x subtract 5. And then we're going to do the same on the bottom. X plus 2 is what we're multiplying, and then we've got the x subtract 2. So now for this fraction, we're going to multiply by x subtract 2. Top and bottom, remember, you've got to do the same to the top that you do to the bottom. So x subtract 2, x plus 5, and then x subtract 2 and x plus 2. It's really important to take care with this to make sure that you're writing the correct signs and you're not getting confused by all the different algebraic parts. So now we have the same denominator for both fractions, so we can write them as everything as on the numerators over that common denominator, which is x plus 2, x subtract 2. So now we're going to start expanding brackets to try and make our life a little bit easier. So when I expand these brackets, we're going to get x squared, subtract 5x, add 2x, subtract 10, plus x squared plus 5x, subtract 2x, subtract 10. And then on the bottom, x squared, subtract 2x, add 2x, subtract 4. So we're going to keep going. We're going to keep simplifying. So I'm going to simplify each of these sets of brackets that I expanded so I have less terms to deal with when I simplify and collect like terms later. So x squared, we have negative 5x plus 2x. So that's negative 3x, subtract 10, plus x squared. And then we've got 5x subtract 2x, which is positive 3x. And then we've got subtract 10. So that's simplified the top, so we're dealing with less terms. Let's do the bottom. So we have x squared, and then we have negative 2x, add 2x. So they cancel each other out. So that leaves us with x squared subtract 4 on the bottom, which is reassuring because that's what we're aiming for in this final form. Let's make the top a little bit nicer to deal with then. So we have x squared plus x squared. So we have 2x squareds. Then we have minus 3x, add 3x. Well, you're starting with negative 3 and you're adding 3x. So they're going to cancel each other out. So we don't have any x terms left on the top. But then we have negative 10, subtract 10. So we end up with negative 20 on the top. No more simplifying is available to us on that denominator. So now it looks similar to this form. Let's check if we can read off our values. So a is 2. That's an integer. That works for me. So a equals 2. B here, look, corresponds to the 20 there. That's a minus. This is a minus. So we're going to put b equals 20, not b equals negative 20, because the signs match there. So we've shown that these algebraic fractions simplify in this form to get integers for a and b of 2 and 20. Question 26. Here is a sketch of y equals x squared. So we've got that positive x squared curve. 26a, the minimum point of y equals x squared is at 0, 0. So this is 0, 0. Write down the coordinates of the minimum point of y equals x squared plus 2. So what we're looking at is the difference between these two equations. The difference here is that one's got plus 2 on the end. And because that plus 2 is not combined with the x within the squared term, it relates to the y coordinate. And what that means is this graph has shifted up 2 places on the y-axis. So currently we have x and y coordinates of 0 and 0. But if we're adding 2 to that y coordinate, it becomes 0, 2. 26b. The graph y equals x squared is reflected in the x-axis. write down the equation of the graph after this transformation. So if this is the x-axis and we reflect this curve over it, we're going to end up with the curve looking like this, which is actually negative x squared. So the equation of the graph after this transformation would be y equals negative x squared. There's no other numbers or anything here because that point there is invariant. That point there will stay at 0, 0 whether we reflect over the x-axis or not. And then 26c, y equals x squared is now transformed to give y equals x plus 3 all squared. Describe fully this single transformation. So up here, this difference in the equation was not attached to the x and the squared term, so it dealt with the y coordinates. Here, this plus 3 is inside the brackets, it's inside the squared term, so this is dealing with the x coordinates, or what we do to move this graph sideways, so left or right. The y deals with up and down. And what we have to remember is when we're dealing with inside those brackets with that x coordinate, we're doing the opposite. So plus 3 doesn't mean go to the right 3 like transformations. It means do the opposite. So we're going to translate 3 units left, which would be a vector of negative 3, 0.